question. I was reading earlier today the gentleman, the physicist behind the, I'm not going to recall correctly, but the telescope, the James Reddy telescope, maybe, that's going up.
It's a James Clerk Maxwell telescope.
The Webb telescope.
Yeah, I think
so.
Yeah.
Yes.
Okay. So he was. I read something earlier today that he was quite skeptical about extrasolar human activities, like leaving the solar system as people. Or,
extrasolar?
Yeah. So like leaving the solar system as individuals or people or as a society.
He's skeptical about space travel.
Yeah. Yeah. Or long-term space travel because of distance. Okay. So my question is, what do you foresee quantum computing opening up in terms of exploration outside the solar system? And potentially, how does that, like, are the computers going to go there for us?
Okay, so predictions about the future are mostly useless. Okay, so bear that in mind.
Economists know that very well, don't they?
They're almost always wrong. So with that in mind, I look to fundamental physics. What new facts have we learned about the universe which might open new technologies? So just in the last 10 or 15 years, we've learned that space is full of energy. This is pretty amazing. Empty space is not empty. In fact, 72% of all the energy, there's a lot of energy in the universe, in one teaspoon of sugar, there is enough mass energy to blow up a city. 1 teaspoon of sugar, that's just E equals mc squared. I mean, the world around us is full of energy, okay? And you can exploit that in nuclear energy. But even that is piffling compared to the energy in space. The energy in the type of stuff we're made of, ordinary matter, is just 5% of the energy in the universe. The energy in empty space, which is just spread everywhere uniformly, is 72%. So there's a ton of energy in the universe. And the big question is, can we use it? Now, fascinatingly, the Higgs boson discovery tells us much, much more than there is a particle called Higgs boson. That's what happened in the press. This is particle. But in fact, the real discovery, the implication is that all of space is full of this Higgs field. It's everywhere. And this Higgs field gives all of our particles their mass, it controls how they move through space. So we now think of the vacuum, empty space, as full of Higgs field, full of energy. It's a very, very interesting place. Okay? And from the discoveries of the Large Hadron Collider, you can extrapolate the properties of the Higgs field in empty space to the state of the universe if the Higgs field was much bigger. And the weird thing is that you discover, the data tell you, that the vacuum we live in is not the only vacuum. There's another one that has lower energy. And so that if you had the right conditions, you could actually make a little bubble of the other vacuum within our bubble, within our vacuum. And that other bubble, because it has lower energy, would grow. And you could use the boundary of the bubble, like the surface of the bubble, to drive your spaceship. And similarly with dark matter. Dark matter has a lot of energy. You may be able to power spaceships with dark matter. There's an amazing fact about space travel, which is, you might say it's all irrelevant to us human beings because the universe is 14 billion light years across. It's a very big place. Now, we only live for 100 years if we're lucky. How on earth are we going to explore the universe if we can only go at the speed of light and it takes 14 billion years to get across the universe? So it's all irrelevant, forget about it. That's dead wrong. Because according to relativity, when you travel at nearly the speed of light, space shrinks, space contracts, distances get shorter. So it turns out that if you made a spaceship which could travel at 1 g, just the acceleration we feel all the time, Okay? And so we'd be absolutely comfortable sitting here, we'd leave the Earth's atmosphere, and we'd be going along at 1g, and we'd just feel absolutely normal gravity. If you did that, but you keep the 1g going for 23 years, you're on the other side of the universe. That's what relativity means. And so this entire spectacular universe is actually on a completely human scale. And yeah, I believe that's probably what's coming.